All right. We're also going to talk about graphing inverses by just switching x and y. And what I mean by that is, if I can graph this line on this axis, then I can switch all the points and produce the inverse without even calculating it over here. So if I had an equation like y equals 3x minus 4, I could find a couple points. It's the y-intercept of negative 4. 1, 2, 3, 4, be a dot. Slope right here is 3, so I'd go up 3 over 1, and up 3 and over 1. And I could produce the line that I'm looking for right here. So if this was f of x, then I could actually calculate the inverse just by looking at these points. And what I mean by that is, let's take a look at this point here. This is 0, negative 4. So if I switch the x and the y, it would produce the point negative 4, 0. Which means the inverse has a point right here. And if I look at this point right here, which is 2, 2, then the inverse, if I switch x and y, is actually going to be the exact same point, which is 2, 2. So I know the inverse also has a point there. So with 2 points, I can draw any line. So if I know 2 points that are on the inverse, I should be able to draw a line that goes through these points right there. So without ever calculating the inverse, I know that this is where the inverse of x is, of f of x. Once again, I can check by drawing my line of symmetry or my line of reflection. That's the line that goes exactly smack dab through the middle of this thing. So this dotted line, that would go through here would actually, wow, that's pretty good, Jim. That would actually hit the middle, would look like that. So it should reflect itself over the top of this line. So let's talk about something that looks a little different. I could graph a parabola, for example, y equals x squared minus 3. So remember, if this is a parabola, then the vertex of this parabola in HK form would be 0, comma, negative 3. So 1, 2, 3. And since it's a parabola, it would go up 1 and over 1. So over 1 and up 1. It would go over 2 and then go up 1, 2, 3, 4, which is 2 squared. So I would have this parabola right here. So when I go to graph the inverse of this function, it's going to be pretty different. Since this here is the point 0, negative 3, the inverse should be at negative 3, 0. So that means the inverse should have a point right over here. And since this point right here is the point 1, negative 2, the inverse should have the point negative 2, 1. And you'll notice there's already a point at negative 2, 1 right there. And we'll notice that this one reflected here, so the inverse is going to reflect here. Let's take a look at the next point. Next point's way up here. It's going to be at the point 2, 1, which means the inverse should have a point at the point 1, comma 2. Just flip the x and the y. So I go over 1 and up 2, put another dot. So 1, 2, 1, 2 should be a dot there. So you'll see this inverse is the exact same parabola, but it's like it fell on its side. So there's the inverse. Here's the original. We could check. How do we check? Draw a line of symmetry right down the middle of this thing. So if I drew my line of symmetry right down the middle of this graph, everything should reflect itself on that line. And here's the cool thing. All of these points where it connects with this line of symmetry should be on both graphs and should be exactly the same x and y value. Because remember, this is the line y equals x.